Uh, Hello, my friends. I'm Dr. Bahtiyar and I have a PhD on operational research. Today, I will talk about failure rate, which is one of the maintenance metrics. Failure rate, in this topic, we will cover several issues. What are these? I will explain the failure rate with two examples. One example for repairable items, the other example for non-repairable items. And I will talk about difference between MTTF, mean time to failure, and MTBF, mean time between failure. And the last topic, in addition, these two concepts, MTTF and MTBF, I will talk about MTDD, which is mean time to detect, MTTI, mean time to investigate or isolate, MTTR, mean time to repair, and MTRS, mean time to restore. We will talk about these concepts as well in our video. Let's go to the definition. First of all, it is rate, failure rate, it is rate. Rate, as you read on the screen, the rate of which failure occur in a specific time interval is called the failure rate for that interval. When we look at the formula of the failure rate, which is denoted by the lambda, which is Greek letter, number of failures divided by total operating hours. It means, my friends, you can tell to your friends like this: the failure rate, the number of failures within a specific time period, which is denoted by total operating hours. And you will say you will count the number of failures within a specific time interval, which will be corresponding to your total operating hours. Now, MTTF and MTBF. As you see here, the formula, unfortunately, the same, 1 over lambda. MTBF and MTTF formulas are the same, 1 over lambda, which is lambda is failure rate. 1 over failure rate is MTBF. Then MTBF and failure rate are not the same, my friends. They are not the same. One of the reciprocal of each other, okay? And why do we call MTTF to non-repairable items? Because after the failure, we have no option but discard the item, because this is non-repairable item. We have no choice. But for the repairable items, we repair it. After the failure, we repair it, we use it. After the failure, we repair it, we use it. Now, when you remember our maintenance time domain video on my previous videos, you may find it on my YouTube channel. You will come up with this type of concept: uptime, downtime, uptime, downtime, uptime, downtime. Uptime is the failure is operational ready or operational in use. Downtime is somehow it is not operable. It is down. The equipment is on the down. It's not operable due to maintenance, due to administrative, or due to logistics. But somehow it is not operable. Now remember that MTBF 1 over lambda. Now I will give a more the information about the downtime. My friends, let's go over like this. As you see here, my friends, something breaks. Here, pen. Yes, great. Something breaks down, and we get the notice that it's broken. The time between something breaks and we notice it's broken, it is mean time to determine area. After we notice it is broken, we figure out why it is broken. It is time domain for MTTI, mean time to investigate or mean time to isolate. After we figure out why it is broken, now it is time to repair it. Until we fixed it, this is the time domain for MTTR, mean time to repair. And then MTRS. After we fixed it, we sometimes, not always, sometimes we do some operational checks so that we ensure that the system is operational ready. This is the time period for MTTR. MTRS, which is mean time to restore. After the system is operational, until something else breaks for the operational wise, we call it MTTF, mean time to failure. Now, mean time between failure includes all of them. MTTD, mean time to detect, mean time to investigate, mean time to repair, mean time to restore, and mean time to failure. Mean time between failure begins of the beginning of the downtime first until the second downtime something else break. It includes from here up to here, my friends. I think this is pretty sure, it's clear. Now it is time to take a look at the reliability curve, my friends. As the time as shown in the x and failure rate as shown on the y-axis, as you know here, burn-in phase the first period, and the steady state phase on the second period, and wear out phase in the third period. In the first period, as you see here, failure rate as time goes on, failure rate goes down. Somehow it gets fixed somehow in the usage phase, let's say steady state phase. The failure rate somehow it's steady, and then until the end of the period, we call it wear out phase, the failure rate goes up, my friends, goes up. When we take a look at close look at the reasons of the failures during the burn phase and steady phase, we came up with this type of reasons. Inherent primary failures, the first one, which is the failures we should firstly focus on. This is the items that we are interested in should be failed. Or dependent or secondary failures, the item is not is operational, but something else broken. That's broken item cause some defects on our interested equipment. When we call it dependent or secondary failures. Sometimes you have, due to manufacturing problems, improper installations, defective components that we use, incorrect assembly may cause us some failure rates in the beginning of the period. Operator-induced failures or maintenance-induced failures or equipment handling damage can be another factors for the cause of the failure rate in the beginning or burning phase. Let's take a look at the wear out phase. Condition of use, aggressiveness of the environment or wear out failures will be the cause for the wear out phase, my friends. Of course, these two reasons will be a cause for the steady state as well, my friends. Now, I will explain two examples. Question one for non-repairable items, and question two for repairable items. If you are ready, I will explain them for you. I have 10 components. Each component has identical attributes. Each of them has a 600 capacity, and which is a total of 6,000 capacity hours, operating hours. As opposed to 6,000 operating hours, the actual observed operating hours is unfortunately less than 6,000, which is, as you see here, 4,180, because of the first 5 equipment has some defects. That's why they couldn't achieve 600 operating hours. Do you remember the reason? When we remember the bathtub reliability curve, and on the y-axis there is a lambda failure rate, and on the x-axis there is a time. As you see here, the initial phase, 75, 125 to 130, and 325, 525 in the last two. Do you remember the reasons? The primary defects, the secondary defects, and maintenance, operating-induced, maintenance-induced defects. Do you remember the problems here? These are all the problems. Should be accounted for this, explaining the first 5 items. Now it is time to take a look at the lambda, the failure rate. the number of failures divided by total operating hours. The number of failures are 5, and the total operating hours is not 6,000, my friend. This is important. You should take a look at this. Total operating hours, this is actual operating hours, 5 divided by 4,180, which gives us lambda, which is failure rate 0.0011, 1 over failure rate, 1 over lambda, which is 1 over 0.001196, gives us 836 hours. My friends, now since we have a MTTF, mean time to failure 836, I came up with this formula for calculations for repair spare requirements, which is total operating time, which is 6,000 divided by MTTF, which is 836 gives us spare requirements. It's a 7.177. I recommend as at least 7 spare parts for this mission in order to complete 6,000 operation time. My friends, let's continue our first example with modifications. I will explain why I did this modification. As you remember, my friends, we have 10 components and all has a 600 capacity, and the number of failures again 5. I changed the performance, required observed performance of the first 3 and changed the 9th one only. I take the 4th and 5th one as it is, my friends. As you see here, the number of failures again the 5, again the same 5, the number of failures, but the total operating hours, actual operating hours, increased from 4,200 to 5,100 now. And as you see here, performance observed minus theoretical decreased to 900 from 1,820. Now, when we calculate with this modifications, when we calculate the failure rate, number of failures is the same 5, but the total operating hours is 5,100. Our lambda decreases 0.000098. When we take the reciprocal of it to calculate the MTTF, we get 1,020. Do you remember the previous one? 836. 800. It was 836 before previous example. Now it is 1020. Our spare requirements decreased to 5 to 6. From where? From 7 to 8 from the previous example. From 7 to 8 decreased to 5 to 6. Now, do you remember the first 3 increase of the performance? Now, why I made this modification? Because do you remember the Bathtub reliability curve? This is the first initial curve. The performance of the first 5 are less than we expected. This is the reason why we should focus on the initial phase for the non-repairable items. We need to take pay attention to what? To operating induced problems, maintenance induced problems. What else? We have manufacturing induced problems, assembly induced problems. We should take a look at the problem areas closely so that our observed operating hours should be increased. This is the reason. My friends, now I will explain the example for repairable items. We will calculate the failure rate for the repairable items altogether. After this example, you will learn by yourself how to calculate a failure rate for the repairable items. Let's begin, my friends. The green one refers to uptime. It's operational ready and in operation. Downtime, it's not operational. As you see here, a total cycle time from 20.2 up to 4, column M, all the cycle time equals to 169. Total uptime equals to 142, which is the summation of the green ones, and total downtime, which is 27, which is the summation of downtime. The number of failures, 6. How are we going to come up with this number? We will count the number of downtime, 1, 2, 3, 4, 5, and 6. Or total operating hour, again, actual operating hours, not 169. Total uptime is 142, which is total operating hours. As you remember the MTBF formula, 1 over lambda. Lambda is number of failures divided by total operating hours. Lambda is equal to, do you remember the formula? Yes. the number of failures is 6. A total operating hour is 142. Yes, this is correct. Now lambda, this calculation gives us lambda 0.0422, and 1 over lambda gives us MTBF. Mean time between failures is around 23 hours, almost 24 hours. It means, my friends, every 23 hours we will have some failures. Now you may ask me, how are we going to calculate MTTR, mean time to repair? Do you have any question? Do you have any comment? How are we going to explain this? MTTR is equal to, yes, my friends, total downtime divided by number of failures, 27 divided by 6. This result gives us MTTR. I think you understand how we calculate total failure rate for repairable and non-repairable. My friends, let's go over the questions that we should review our questions so that we understand the topic very well. What is the difference between MTTF and MTBF? Yes, my friends, you are right. MTTF and MTBF are different, but the formula is the same, 1 over lambda, right? Great. MTTF for non-repairable items, we call it non-repairable items NR, and MTBF for repairable items. Great. Failure rate is the same as MTBF. Is this true? It is false, my friends, because 1 over lambda is equal to, let's say, 1 over lambda MTBF. You're right. MTBF. Sorry for the improper writing. MTBF. Let's say here. MTBF. It means they are not the same. MTBF calculations includes MTTR and MTRS, mean time to repair and mean time to restore times. Is it correct? Partly correct. Yes, partly. But in addition to these two, MTTR and MTRS, it includes what? Mean time to investigate. Yes, mean time to investigate. The first one. Let's go over this. Mean time to investigate, and then before that, mean time to determine, and mean time to failure. 1, 2, 3, 4, 5 elements will be included. And here let's say the last question. Reliability curve is characterized by increasing failure rate in the initial phase, being steady state in the midlife phase, and decreasing failure rate in the wear out phase. Verify the sentence whether it's true or false. My friends, as you remember here, as a bathtub shape, failure rate here, lambda, and the y-axis, and will be on the x-axis will be time. Increasing or decreasing? Yes, my friends, this is decreasing failure rate in the initial phase, being steady state in the midlife phase, it's correct, and decreasing failure rate, it's not correct, it is in the initial steady state in the steady state phase and increasing in the wear out phase. Thank you very much for watching this video, my friends. I hope you like it. In this video we talk about failure rates, mean time to repair, mean time to failures, and mean time between failures. I hope you understand how to calculate failure rate for both repairable items and non-repairable items. Any question, please write it down as a comment under YouTube channel videos. Thank you very much, and if you like this video, please subscribe to my YouTube channel and share it with your friends. I will be glad.